In this lesson, we're going to take a look at the 5 main types of chemical reactions. The first type is known as the synthesis or the get-together reaction. So if you look at it, you have 2 simple chemicals as reactants, and you end up with one product on the other side. So when you're looking at a chemical equation, you can recognize a synthesis reaction by having 2 reactants and 1 product. So 2 or more chemicals bonding together to form a new substance. Simplified equation would be A plus B yields AB, or an actual example would be sodium plus chlorine yields sodium chloride. Decomposition reaction is when one substance breaks down into 2 or more separate substances. So if we're looking at the chemical reaction, we have 1 reactant, and that reactant is going to split to create 2 products. An example of that would be hydrogen peroxide breaks down to become water and oxygen. Single replacement, or sometimes referred to as single displacement reactions, can sometimes be kind of candidly called the cheater. It's when one element knocks out another element of a compound. So we can say that one compound goes to a dance, and this element, little black dress, comes all on her own. Some point throughout the night, they switch, and top hat starts dancing with little black dress, and a little red bow is left all on her own. So this element knocks the little red bow element out of the compound that she was originally a part of. This can be simplified as AB plus X yields AX plus B. Notice the switching of the elements. So hydrogen chloride and zinc would yield zinc chloride and hydrogen gas. Now, in order to know if a single replacement will take place or not, you have to know how active elements are. So the more active an element is, and in this case, the higher it is on this scale, they will form ions and displace an ion of a like charge. So that means cations will displace cations and anions will displace anions. And the displaced ion will then become a neutral element on their own. So if it's a metal, you would simply write the symbol of that metal. But if it's a non-metal, and if it's one of your halogens, you would have to write it as a diatomic. So let's take a look. If we have aluminum and lead 2 chloride, would that result in a single replacement? Well, we look at that single element that's coming in and recognize that it is a metal. Metals form cations, so we would be looking over here. So we'd find aluminum in our scale, and then we would have to find the other metal, which is lead, and it is further down on the scale. So aluminum indeed is more active, so it would actually displace and replace the lead in the compound. So we would end up with aluminum chloride and lead as our products. Let's try another one. If we have bromine plus iron 3 chloride, would that result in a reaction? Now we'd look and we would say the element coming in on its own is a non-metal, and in fact it's a halogen, so we would have to look at, would it replace the other anion? In this case, it's the chloride ion. So we would find bromine and chlorine in our activity series, and we would notice that chlorine is actually higher up. So since bromine is not more active, it will not displace or be able to replace chlorine from the compound. So if you were given a reaction like this, you would simply write no reaction. The 4th type of chemical reaction we're going to look at is the double replacement or double displacement, sometimes candidly called the swap. So 2 compounds switch ions. So one way to remember it is that the cations just switch partners. So if we have the hat and the bow come to the dance together, the mustache and little black dress come together, at some point throughout the night, they swap partners and end up dancing with each other, and top hat ends up with black dress, mustache ends up with red bow. Sometimes simplified as AB plus XY yields AX plus BY. A real life example, barium chloride plus sodium sulfate will yield barium sulfate and sodium chloride. Notice the barium came in with the chloride, however barium now swaps and is now bound to the other anion, in this case the polyatomic sulfate. Sodium came in with sulfate but swaps and ends up binding with chloride ion. The 5th type of reaction is the combustion reaction. Now this is when a compound burns in the presence of oxygen. So for a combustion reaction, when you look at that equation, oxygen must always be a reactant, and there's always a form of energy produced, most usually heat and light. If you think of a burning candle, you get heat and light. So you have a compound A reacting with oxygen. Usually that compound A, or what's reacting with the oxygen, is a hydrocarbon, or a compound that is made up only of carbon and hydrogen atoms, and we can refer to that as the fuel. So the fuel plus oxygen will yield carbon dioxide and water plus the energy. If we do not have energy, it's not going to be a combustion reaction. The carbon and the hydrogen over here came from the fuel. So for example, if we have methane reacting with oxygen gas, we end up with carbon dioxide, water, and energy. Sometimes, however, there isn't enough oxygen present, and it's called incomplete combustion. In an incomplete combustion, you would also have carbon monoxide, or CO, produced as well. And that's one of the reasons there are carbon monoxide detectors in houses, is when there is a house fire, there's not actually enough oxygen to burn all of the fuel or all of those compounds, break them all down. So it's incomplete combustion and there is some carbon monoxide present. That carbon monoxide, as we know, is poisonous to humans. So summary of the 5 major types of chemical reactions. Synthesis, you have 2 reactants yielding 1 product. Decomposition, you have 1 product breaking down to yield, 1 reactant breaking down to yield 2 products. Single replacement, you have a more complex compound with a simple compound. This simple compound can replace the like charged ion and you end up with a single swap. Double replacement, both compounds are going to switch the ions that they originally came with. So AB plus CD ends up as AC plus BD. Combustion, if there's oxygen as part of the reactant side and you end up with heat and light energy produced, as well as carbon dioxide and oxygen, you have complete combustion. If you have the presence of carbon monoxide, CO, you have incomplete combustion.